Hey, AP Physics students, how about a little bit of help regarding T14.1? T14.1 involves something called the work function. Now, the work function is the minimum angle, or the minimum energy needed to be absorbed by a photon of light so that an electron is ejected. So in number 7, it says that the surface, the metal surface, has a work function of 3.68 electron volts. Recall something kind of useful. There is a conversion that you'll go back and forth between. And the conversion code goes like this. 1 electron volt is the very same as 1.6 times 10 to the negative 19th joules. Those are convertible, so you want to use that. Remember the work function formula. The kinetic energy maximum is equal to H times F. Recall, E equals HF is the formula for the energy of a photon, minus W0, which is the work function. So the maximum kinetic energy is equal to the energy of the photon, that's E equals HF, minus the work function. That's the minimum that you need for ejection of an electron. So that's what you're going to use. Only one more hint to give you with this one. One of the things that's very useful in every one of these problems is to recognize, since velocity is frequency times wavelength, but we're always dealing now with velocity that is the letter C. So instead of V, we could use C. So what we've discovered that is very useful is instead of using F here, it's very useful to realize that F is the same. If you solve for F, it's the same as the velocity, which we'll call C, divided by lambda. And that is a useful way to do number 7. Now let's look at number 27. Now number 27 says the width of the central bright fringe in a diffraction pattern on a screen is the same exactly, whether it's an electron or red light. Well, what basically that means, at least a way to get started at this, is that the wavelength, the de Broglie wavelength that you read about and we talked about of red light must be the same as the actual wavelength, or the wavelength of red light must be the same as the de Broglie wavelength of the electron. Okay, so again, let's say that the width of the pattern is the same in either circumstance. That means the wavelengths are the same. Okay, now I'll give you one more hint regarding this problem. You recall from our formula sheet that the lambda, the de Broglie wavelength, is the same as h, Planck's constant, divided by the momentum. That should be very useful for you to solve this regarding electrons. Have a good time.